Welcome to Great Northern Cascade Division in N-Scale. In this video I wanted to talk a little bit about some of the design considerations, some of the challenges about the lighting that's going on here on the model railroad. I started recording this and I was talking about this as I was doing video for installing the first 100 plus or so feet lighting on the upper deck here, but I thought it ended up being about 10 minutes or so, and so I thought, okay, let's put this out into its own video. There's been a lot of really good comments that have come through on YouTube. People have sent me messages and emails and things like that as well. I do appreciate all of the feedback, but there are additional things that you need to think about just because of the scale of this railroad. I'm going to be looking at over 350 feet of lighting by the time this is in, so I need to think about power draw, the heat output, the cost of running, cost of buying them, time installing them, things like that. So hope you enjoyed this one. Please do keep the comments coming. This is, again, just more of an explanation, some of the challenges that are going on here, why I then went with the SE5050 LEDs. Do check out some of the other videos that I have where I actually dig into those SE5050 LEDs, the different ways that you can power them, mount them, things like that. And then again, that video where I install this first 100 plus feet on the upper deck. All right, so before we start installing all of those lights, I wanted to spend just a few minutes kind of talking about what we have going on in the basement and why I don't complain, but why I talk so much about kind of the difficulties of lighting down here. And there have been a number of YouTube comments, a few people have reached out via email. I genuinely do appreciate it, even if I kind of appear dismissive. The kind of challenges down here that I'm looking at really come down to scale, the kind of size of the layout that we have, okay? So first one I need to think about is power draw. How much power are the lights going to draw? And this doesn't matter what kind of lights you use. You could use fluorescent strip lights, you could use LED strip lights like the 3 and the 4 foot long kind of tube lights. You could do strings of LEDs, 16, 32 foot cheap LEDs that you can find on Amazon. You could do more traditional kind of actual light bulb type bulbs. You know, you can hardwire them in and then you can put these bulbs in. Every bulb that you have, or every LED that you have, draws a certain amount of power. And so for traditional kind of light bulbs, that's measured by the bulb. For strip lights, that can be measured by the bulb itself, although typically it's over like a 3 foot length or a 4 foot length. And then for LED lights, like the actual rolls of lights, that's usually measured again by the foot. So a typical light bulb is usually about 60 watts. You can go to then LED bulbs, and then you're getting down to between 8, 10, 11 watts per bulb, something like that. With the 3 and the 4 foot shop lights, the LED ones typically are about 20 watts for the 4 foot length, for example. All right, so if you then start to break that down by foot, a 4 foot LED shop light is about 5 watts per foot. And I'm going with averages. I'm going with some just quick ones that I found online. Yes, you might be able to find other ones, but you're looking at about 5 watts per foot on kind of the strip lights that you get. If they're not LED strip lights, if they're more the kind of older school type fluorescent bulbs, then it's a little bit higher than that. The LED, the roll of LED lights that I'm going with are about 2.3 watts per foot. Why does this become important? Because as you scale it up, and as I'm looking at probably is over 350 feet of lights, then I have to kind of pay attention, one, in terms of how much is it going to cost me to run these lights, but then also how much can I put onto an electrical circuit down here in the basement. So if we went with the 4 foot LED strip lights that are about 20 watts in total, about 5 watts per foot, to do the whole basement, we're at right around 1,800 feet. And again, this is really rough math, but it's just to kind of give a sense of why I kind of push back at times when people suggest certain different light sources. About 1,800 watts for the lights if we went with those LED strip lights. It'd be more if we went with incandescent bulbs or even just the LED type bulbs, because you need more of those, and so it ends up, you know, about 1,800 watts, probably is more, 2,000 watts maybe. Now, a typical 15 amp circuit is about 1,800 amps at total load. From what I've heard, from what I've been told by electricians, from what I'm read, you typically only want about 80% load, so that brings you down to about 1,440 watts. That will go on a 15 amp circuit. So okay, you can split it across 2 circuits. And I've seen plenty of layouts where they do exactly that. They have 2, 3, 4 circuits sometimes, and the lights are kind of spread across these because otherwise it's too much load on one circuit. So that's part of what you need to think about, how much draw is there going to be on the circuit. So I have a dedicated circuit, 15 amp circuit, that can run only LEDs. That's the quadplex that I had installed, and that's also then switched. So I can throw a switch and it will turn on all 4 of those outlets, and that would then turn on all of the lights. That's kind of the theory behind this. If we did any other kind of light source and we're going across more than one circuit, well, now I can't do that. Now I've got to go around individually turn a bunch of lights. Absolutely I could, but I'm lazy. And it's just the ability to be able to control the light separately from anything else that's going to be on there is kind of important. If we then look at the Digitrax system, okay? So the Digitrax system that we put in, it was a very basic set. It started out with like 5 amps. In total, what I kind of mentioned in that early Digitrax video is there will be a 20 amp power supply, because there'll then be 2 dual 5 amp boosters. So in total, we're going to be looking at something like 25 amps total across the DCC circuit. It's not actually then 20 amps directly, or 25 amps directly onto a 15 amp circuit, just because again of how the math works. The way that the power supplies work is they actually draw less and can output more. I know, I'm not an electrician, but basically the 20 amp power supply for Digitrax, I think, draws 463 watts, somewhere around that. I could be a little bit off on that. 463 watts, but it can then power up to 20 amps worth of boosters, which is actually getting more like 2200 watts, okay, just because of the way that the converter inside of it takes the power, spools it up, and then spits it out, right? Magic pixies, as Rich tells me. So I've already got another dedicated circuit that is really for things like DCC, because when that whole system is in place, when we've got the command station and we've got that 20 amp power supply for all of the other boosters, when we've got all of the PM74s and the power supplies that go with that, when we then add in some of the other things that are going to be in, I'm at about 900 watts, almost 1,000 watts worth of power draw. Again, we got to think about power draw once the entire DCC system is up and running. So again, we're getting close to that 80% load point for a 15 amp circuit, right? So now I'm already down 2 circuits, one for all my lights, one for all my DCC. I do then have another 15 amps, actually, I think, yeah, it's another 15 amp circuit on my workbench, where I've got a bunch of stuff. I've got air compressor, I've got the Raspberry Pi, I've got some lights, I've got a shelf, 8-foot shelf layout that I'm working on as well. So I'm not going to be getting close to fully loading that, but the idea is that I have power available, but I can't throw a whole bunch of lights in that are going to take 2200 some watts, because I'm then starting to eat into other circuits that are already starting to get close to their load. The other thing to think about is how many outlets do you need, right? So for the LED strip lights, usually what I've seen is you can connect a maximum of about 6 or 8 of those together. So you can have one power cord that runs into an outlet into a strip light, and then you can connect, 6 or 8 total lights. And then you need to have another power outlet, another power outlet, another power outlet. And so again, on something like the Center Peninsula, it's 24 feet long. I've got 3 levels, and then I've got probably 8 feet, 10 feet of lights that I need to go around the turnaround. That's a whole lot of lights. That's way more than a single outlet, and I don't have any outlets in the Center Peninsula, okay? So now I've got to start thinking about, I'm running extension cords around to plug lights in. That maybe becomes a trip hazard, that maybe becomes a bit of a safety hazard, fire hazard potentially as well. I don't really want to get into that. And then there is, again, just how much does it cost to then run those lights? In total, the LED lights that I'm looking at 2.3 watts per foot roll in at about 850 to 900 watts in total once the entire layout will be lit up. So again, if we look at just the basic 4-foot lights that were going to be 20 watts in total, 1800 watts, I'm at less than half the power draw, which means the running costs, the operating costs when those lights are turned on are going to be a lot less compared to the kind of 4-foot shot bulbs. So that's just kind of a bit of a background as to why some of this is important, why this is a little bit different maybe than a slightly smaller layout that you might be building, where you can get some of those 4-foot shop lights, where you could get some of the cheap LED lights off Amazon. Same kind of thing. Those cheap LED lights on Amazon, the strings of lights that typically come in a 16 or a 32-foot roll, they do have a lower power draw, kind of like the LED lights that I am going with. They're not quite as bright per lumens per LED on them though, so you typically need a little bit more to get the same amount of light, but you typically can't daisy chain those together in quite the same way unless you then put in a separate 10, 15, 20 amp power supply, which you can do, run additional wiring to kind of hardwire it in. There are ways to do it, but again, the complexity, the time, the cost starts to add up, and now you're almost getting close to what these AC5050 LED lights that can go up to 150 foot on a single power outlet can do. So that's just kind of some math, that's kind of some background. Again, I do appreciate people that are offering suggestions, but when I kind of caution things that we now have to go up in scale, both in terms of cost, both in terms of complexity and in terms of time, like these are some of the things that I have to think about on this kind of large of a layout. But again, please keep coming up with ideas and suggestions where you see them. Just kind of temper that with, I might push back because I may well have already thought about it, or as I do think about it, say that's really cool, that's a really good deal, it's a really good idea, but when I try and scale it up, maybe it just isn't quite there. Okay. All right, so that was just a quick brain dump and me kind of rambling as I go through things, but hopefully it gives a little bit more context now in terms of the railroad that I'm building down here, why I've gone for the lights that I have, why I dismissed and discounted some of the lighting options and things like this. Again, everything's all down to preference. It's your railroad. You can do whatever you want. This is just how I've chosen to do this. There are other people that have been interested and sent messages wanting to know more about the AC5050 LEDs. Honestly, you can use whatever kind of lights that you want. Okay, if you have got some shop lights, the 3 and the 4 foot strip lights, perfect. If you've got some of the 16 or 32 foot cheap LEDs off Amazon and they work for you, again, great. It's your railroad, do what you want. Everyone has their own preferences, everyone has their budgets and things like that. But hopefully this has given a little bit more insight as to where things are going here. Hope you do check out those other videos where I dig more into the lighting, and another video where I actually install this first set of lighting. Overall, I'm pretty happy with it, and I think I probably made the right choice. But do like, subscribe, and follow along so you can kind of see additional progress as I go ahead and start to get some track down, start to run some trends, and in time install another 250 some feet of lighting to kind of wrap up the stuff here in the basement. Take care. Bye bye.